Hey guys, so welcome back. So we've been off for about 2 weeks break. So since we're going to be starting this remote learning, this distance learning, um, just kind of wanted to start off with a lesson that we kind of have already talked about. But since we're going to be learning from home and we're probably going to be doing this unit all based from home, I thought what I would do is I'm changing it up. So the notes that we were using, we're going to change and do these notes because I have a digital copy with the answers on them as well, so I can send those to you. So on Schoology, I'm going to be posting everything that we've done here with a little bit of extra because you'll notice there's going to be a lot of problems that I skip. But on the filled in notes that I post on Schoology, you'll see all of those are done. So you can always just do extra problems and check. But I went ahead, I posted the blank one, and I'm posting the one with all of the answers in it. So if you would like to just kind of jot down some notes while we go along, that'd be great. You can either jot down on a piece of paper. If you have a printer, you can print this out and then jot down as we go. Or you can just kind of follow along, do some problems on your own on a piece of paper, and use the notes that I'm putting on Schoology to check in with that. So for today, we're going to be doing this rate of change slope that we started talking about right before we left. We talked about rate of change and slope. We talked about how they are actually the exact same thing. Rate of change, if we look at it, rate of change is basically a ratio, which means it's a fraction. So rate of change is a ratio that shows how one variable changes in respect to another. So how x is changing in comparison to how y is changing. And we keep that ratio going. And so that, when it's on a linear graph, is called a slope. So when it's on a line, our rate of change is actually called slope. We also were calling it constant rate of change. So all of those are names of the exact same thing, and they mean the exact same thing. But we're math, so we like to have lots of vocabulary in there. So we do have to know the difference between them. So, and how they are similar. And when someone's talking about a slope, they're talking about the rate of change, but on a line or in a linear graph. Slope is a main thing that we're going to be talking about today. You had a slope worksheet that I sent home with you on the Friday, and this is something that should be familiar. We talked about slope guy and doing slope problems, but I just kind of want to do a refresher for today. Keep it simple and hopefully bring back some of those memories of what we were doing. So slope. Slope is written as a ratio of the vertical change to the horizontal change. Now, the vertical change is the rise to the run. So when we're talking about it, remember we were talking about, we count how high it goes and then how far over it goes, or how low it goes to how far over it goes. And so it was rise over run is what we were saying. The slope remains constant for any 2 points on the same line. So I can choose the first 2 points, or the first point and the fifth point, or the second point and the third point. No matter what, if it's a line, the slope will stay the same no matter which 2 points you choose on the line. Slope is written as a fraction. So it can also be a whole number. So a whole number or an integer. So when we talk about slope, the one thing that we have to know is that it can't be a mixed number, because we are talking about a comparison between two numbers. So we're not making it into a mixed number. So it's a fraction, and we keep it in simplest form. The variable that we use for slope is m. You're going to hear us talk about m a lot. M is just simply meaning slope. And that's because eventually when we put it into slope-intercept form, which means putting it into an equation, we use the term m when we're representing slope. Before we left, we already talked about the types of slope. We talked about how there is a positive slope. That's always the line that looks like that. We talked about how there is a, negative slope. Then we talked about the one that goes horizontal. There it is. It's not letting me click that line. So we're going to try the next one. See if it's working. We have our undefined and our zero slope. And since it's not letting me click, I'm going to go ahead and make a new line for everyone. So sorry about this. All right. So the zero slope, if you remember from Slope Guide, which hopefully I have enough time and we can go over Slope Guide again. But the zero slope goes horizontal and the undefined slope goes up and down. And if you can recall, the zero slope was the mouth of Slope Guide, and the undefined was the nose because we put a U at the bottom. So anytime we're looking for a slope on a horizontal line or a vertical line, we are talking about a zero slope and an undefined slope. When we're looking to find slope on a graph, we talked about that. It's counting. So you got to make sure that you're counting, and we have to make sure that we're counting continuously. So for instance, for this one, you're going to count up and then over. So here I'm going to go ahead, I'm going to count up and I'm going to count over, because what I'm doing is I'm counting my rise over my run. And so when I count up, I get 4, and then when I count over, I get 5. Now you'll notice I stayed on the same side. So I'm counting 4 up and 5 to the right. That means both those numbers are positive. So that's why it's 4/5. And I also know that this slope is going to be positive because way back here, a line that goes that way is a positive slope. Number 2, right away, I can tell you it's going to be a positive slope. And then I go ahead and I count my rise and my run. And if I go ahead and I count how many spaces there are 6 spaces. And then if I count over, I have 3 spaces, which means I have 6 over 3. Now slope, we can't change it to a mixed number, but we can change it to a whole number. And so we would simplify this one to being 2. Number 3, you can see it right away. What kind of slope is it? Is it going to be a positive or is it going to be a negative slope? Hopefully you said negative. So because it's a negative slope, I'm still going to go ahead and count my rise, which is actually going down. So it's not really my rise, but it is. So my rise, my change in y over my run. And when I count that, I end up with -2 down and then over 6. Now when I did that, if I simplify it, it simplifies to 1/3. But I put the negative out front, and I put it out front because it doesn't matter if it's on the top or the bottom. If I only have one negative, the negative can just shoot out front, and it can just represent the whole fraction. All right. So now I'm going to go ahead, and we're going to keep doing this. I just wanted to talk about 2 more in particular. Number 5. See this line? We already know what the slope is without doing any calculations or any counting. We already talked about it. So if you know what it is, I would say shout it out, but shout it out. You never know. So this slope ends up being a undefined slope. And then the other slope that we look for is number 10 right here. This slope is going straight across, so that's horizontal. That means that there is no slope. There is no change in level. So therefore, this slope is 0. So that's finding your slope on a line. So if I have the line, I'm just counting. Now what happens when I don't have the line? When I have just 2 points, so just 2 data points, my 1 point and then my 2nd point, how do I find the slope? Well, I use the formula, which we talked about, which is the change in y over the change in x. Now, my change in y is y2 minus y1 x sub 2 minus x sub 1. And we just have to remember that the 2's and the 1's don't really mean anything other than the 1's come from this pair and the 2's come from this pair. That's really about it. So if I'm looking at number 1, if I'm trying to find the change in slope, the first thing I'm going to do is I'm going to claim the first point to be my 1's and the second point to be my 2's. So I plug it into my formula. 12 minus 8, 3 minus negative 13. And then I'm simply doing math. But this seems like a really simple process, but we have to slow down. We have to slow down because we have our integers. We have our negative numbers. This is where we make our silly mistakes. This is where we go too fast and our brain is working too fast and we end up making silly mistakes. So I want you to slow down. Think about what you're doing. Remembering that when I'm subtracting a negative, it's actually adding a positive. And so here I'm getting an answer of 4 over 16, which simplifies to 1/4. And so therefore my answer here is 1/4. All right, let's do another one. So we are going to do, I'm just checking, sorry guys, I just have to quickly look at right here. There we go. Okay. We're going to scoot down to number 5. Oh, sorry, I clicked that a little too quickly. On number 5, if I'm looking at this, I'm claiming the 7, 3 point to be my number 1's, and then I'm claiming my 6, negative 2 to be my number 2's. And so I'm doing my y sub 2 minus my y sub 1, and my x sub 2 minus my x sub 1. So negative 2 minus 3, and 6 minus 7. When I do that, I get negative 5 over negative 1, which equals 5. I have a negative and over a negative that actually equals a positive. And so therefore, my answer is actually positive, which means my line was a positive slope. Okay. Now we're going to go down to right here, number 7. Number 7, if I claim that the negative 7, negative 4 is my sub 1's, and my 2, negative 7 is my sub 2's, I would go ahead and plug in. Remember, I'm just using that formula. Y minus y, x minus x. The biggest thing that you have to remember is that you're keeping your 2's first and then your 1's second, which seems so weird. So we have our, and now it's not letting me click again. I'm having the same problem. Let's go down to number 9. I'm so sorry, glitch. So with this one, we go ahead, we look, we've got, I made the 4, negative 13 my sub 1's and the 8, negative 8 my sub 2's. And so with that, I'm looking and I say negative 8 minus negative 13, 8 minus 4. That gets me 5 over 4. Notice I didn't change that. Notice I didn't make it into 1 and 1/4. You will never, ever, 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 never change a slope into a mixed number. And so we just have to be careful that we remember that we're not doing that. Okay. We're going to scoot back up to number 8. To plug in this one, I plugged it in, and what you'll see here is I end up with bottom, and that was what I kind of wanted you guys to see, is that I ended up with a negative on bottom, and that's okay. The only thing is when I go ahead and I write it down as my answer, is that I write out so that that negative is out front. Are you wrong if you leave it on bottom? Absolutely not. It's totally fine. You will not be marked off ever, but it just seems more proper to put it out front. So we've done slope on the graph, slope with 2 points, and I've got a couple more with 2 points. I've got these special cases here. Why do you think they're special? We'll see. Well, here I went ahead and I plugged in this. Again, I have my first one as my ones and my second one as my twos. Sorry, it's backwards. My video's flipped for some reason. And when I go ahead and solve that, I get 0/6. My slope is absolutely okay. When I have 0 on top, that just means I have a 0 slope. If I have a 0 slope, what kind of line is it? If I have a 0 slope, you might say that my line is going to be, so it'll be a horizontal. Okay. This one is another special case because when I fill it out, I end up with a 0 on bottom. If I have a 0 on bottom, what does that mean? A 0 on bottom means that it's undefined. And so if it's undefined, one, I know it's a vertical line. Okay? But I also know that it's undefined. So we need to always remember that if a 0 is on bottom, it's not a big deal. It just means that my answer is undefined. All right. I've got one more thing for you. So again, we've done from a graph, we've done from 2 points. Now it's from a table. Can we find graph from a table? Graph from a table is the same thing as 2 points. The only difference is the 2 points. So for sake of I just always picked the first 2. So I picked the first 2, I plugged it into my formula, and once I plugged it into my formula, I ended up with a -10/4, which you all know that is not an okay answer, and so I would have to simplify it. When I simplify it, I get -5/2. So my answer to this one would be -5/2, 5/2. I did number 19 as well, just to show you that it's the exact same. And again, I just picked the first 2. You really could pick any single one of them. It doesn't matter. No matter where you pick it from, you're still getting the same answer. I just picked the first 2 because it seems to make sense to me. So again, slope is, there's my slope. And I go ahead, I get the answer, 0/4. Does that mean my answer is 0? Or does that mean my answer is undefined? That means my answer is 0. So if my answer is 0, then I also know that it's a horizontal line. Okay, so that's it for today. I really just wanted to go over formula. I just wanted to go over slope and the formula of slope and how to find slope. So we found it from a graph, we found it from 2 points, and we found it from a table. Those are the 3 things that I need you to practice. And so I'm going to go ahead, I'm going to post on Schoology a couple problems that I want you to do today. And then you'll go ahead and you'll put your answers in on Schoology as well. So if you just kind of follow along on that agenda on Schoology, that's what we're going to be doing for today. And then you're done with math for the day. I miss you guys. I hope everyone is doing well. And I hope to talk to you guys soon.